Welcome. So today we shall be looking at Kirchoff's laws. Under Kirchoff's laws, we have the first law, which is the current law, and the second law, which is the voltage law. So the current law states as follows. At any junction in an electric circuit, the total current flowing towards that junction is equal to the total current flowing away from the junction, i.e., summation of currents in a junction is equals to 0. So I'm going to use the following illustration. We are having a junction, current I1 bringing into the junction. We also have I2 bringing into the junction. And we are having the remaining 3 arrows removing the current from the junction. That is the I3, I4, and I5. So when we get the 2, we are going to have I1 plus I2 is equals to I3 plus I4 plus I5. Then you you take the I3 and I4 and I5 to the left-hand side of the equation. The currents are going to cancel out, and you're going to remain with 0. The second law states as follows. In any closed loop in a network, the algebraic sum of voltage drops, that is product of current and resistance, in a loop is equal to the resultant EMF. So let us look at problem 1. It's as follows. Determine using Kirchoff's laws each branch current for the network shown below. So the first step is to put in the direction of your loops. So in this particular circuit, we are having 2 loops. The direction of the first loop, basing on this source, negative, positive, we are going to have it in a clockwise direction. Then loop 2, basing on this source, we are going to have it in anti-clockwise direction. The next step, to put in our currents. So basing on this source and basing on the direction of loop 1, we are going to have our current flowing in a clockwise direction. So because it is found in loop 1, let us name it as I1. Now, using Kirchoff's first law, which states current entering a junction is equals to current leaving the junction. So I1 is bringing into this junction. So meaning this one is coming out and also this one is coming out. Now basing again on this source, we are going to name this current as I2 because of this source. Let us name it as I2. Now using Kirchoff's first law, we said I1, which is bringing into the junction, is equals to current out of the junction. Now, current out of the junction is I2 and the unknown current, X. So you're going to say is equals to I2 plus X. So how do you get this unknown current X? By moving this one to the left-hand side. So you're going to have I1 minus I2 is equals to unknown current X. So let us name it as I1 minus I2. After doing that, you come and form your equations. Now because you're having 2 loops, we are going to form our 2 equations. The first equation, we're going to call it as equation for loop 1. Equation for loop 1. Now in equation for loop 1, we are going to use the voltage laws in order for us to come up with our equations. Now the voltage law states the algebraic sum of voltage drops, that is products of current and resistance, is equal to resultant EMF. So you're going to equate the total EMF in that particular loop to be equal to the products of current and resistance. So in our loop 1, we have E1 and E2. Remember, this E2 is being shared in both loop 1 and loop 2. So when we'll be forming our equation for loop 2, we shall still use E2. But E1 is not found in loop 2. But E2 is found in both loop 1 and loop 2. So you're going to have E1 plus E2 is equals to, so we have E1 plus E2 is equals to, the first resistor we meet immediately after this source is R1, and the current flowing through this R1 is I1. So the current flowing through this, the current that passed through this is I1. So I1 R1 plus, we are still in loop 1. So the current flowing through this resistor, the next resistor is R2, and the current flowing through this is I2. So we have I2 R2. So that one is our equation 1. We substitute in our values. So we have 4 plus 12 is equals to 0.5 I1 plus 2 I2. So that one is our equation 1. So let us call it our new equation. Now let us form equation for loop 2. Equation for loop 2. In equation for loop 2, we are going to look at loop 2. Loop 2's direction is anti-clockwise. Loop 2's direction is anti-clockwise. And we only have one source. We only have one source. So we are going to have E2 is equals to, the first resistor we meet in loop 2 is R2, and the current flowing through it is I2. So I2 R2 plus, the second resistor we are meeting is R3, and the current flowing through it is I1 minus I2. But remember, the direction of our loop is anti-clockwise, and our current is coming in a clockwise direction. So therefore, we are going to negate this current. So you're going to have minus I1 minus I2. You multiply by R3. So let us substitute in our values. So E2 is, the value for E2 is 12, which is equals to 2I2 minus, the minus is coming from multiplying positive and a minus. When you multiply positive and a minus, you end up with a minus. Into bracket, I1 minus I2, you multiply by R3. Now the value for R3 is 5. So you can just have it as 5. So we substitute further and we open the bracket. We are going to have 12 is equals to 2I2 minus 5I1. When you multiply a negative and a negative, it's supposed to give you a positive. So you're going to have plus 5I2. We collect like terms. We are having 2I2 and 5I2, which will give us 12 is equals to minus 5I1 plus 7I2. So this is our new equation 2. So now we have formed our two equations. So let us solve them simultaneously, either by elimination or substitution. So the equations are 4 plus 12 is equals to 0.5 I1 plus 2 I2. Then the second equation is 12. So before the second equation, let us simplify this one. 16 is equals to 0.5 I1 plus 2 I2. Then our second equation is 12 is equals to negative 5 I1 plus 7 I2. So we solve simultaneously, either by elimination or substitution. So before making I1 the same, you can see the I1 has a 0.5. So we have to remove the 0.5 by multiplying everything by, in the first equation, by 10 by 10. So we are going to have 160. So we are going to have 160 is equals to 5 I1 plus 20 I2. So 160 is equals to 5 I1 plus 20 I2 after multiplying everything by 10 in order for us to remove the decimal on I1. So we are having 160 is equals to 5 I1 plus 20 I2. Then we have 12 is equals to negative 5 I1 plus 7 I2. We make I1 same. Already it is same, so we don't have to make it same because already it is 5 and 5. So we are going to use elimination. In order for us to eliminate, this one is a positive and this one is a negative. We are going to add. So 5I1 plus minus 5I1. So positive and negative, when you multiply, you get a negative. So you're going to have 5I1 minus 5I1. You get a 0. So we have eliminated the I1. Then the next one is 20I2 plus 7I2. You get plus 27I2 is equals to 160 plus 12. You get 172. So over 27 over 27. You get I2 is equals to So I2 is equals to 172 divided by 27. You get 6.37. 6.37 amperes. So that is our I2. In order for you to get I1, you pick either equation 1, or 2 and substitute in order for you to get the value for I1. So after getting the value for I1, you come and substitute in the equation I1 minus I2 in order for you to get the current flowing through resistor 3. So after calculating, I have gotten I1 as 6.52 amperes. So I1 is equals to 6.52 amperes. And the current flowing through R3, is equals to 0.15 amperes. So that is how you solve this particular circuit by Kirchoff's laws. So we have used both the current law and the voltage law. So problem 2, the question is as follows. The figure below shows electric circuit. Using Kirchoff's laws, determine the current flowing through the 5 ohm resistor. So our first step is to put in our loops, direction. So in the first one, negative, positive, negative, positive. We are moving in a clockwise direction. So loop 1. In the second, we are having the source here. So you're going to move in a anti-clockwise direction, loop 2. The second step, let us put in our currents. So this one, we are going to name it as I1. This one, we are going to name it as I2. The source is here, so let us name this one as I2. Applying Kirchoff's current law, current entering a junction is equal to current leaving the junction, So this current is a summation of I1 and I2. So now let us form our equation. So equation for loop 1, equation for loop 1. How many sources do we have? 1, 2. So let us name this one as E1, E2, E3. Let us also name our resistors, R1, R2, R3, R4. So we come and form our equation. So in loop 1, we're having 2 sources. Now the sources, they are in the direction of the loop, which is a clockwise direction. If we could have been having here, let's say, positive and negative, if the terminals would have been interchanged, then the 2 sources would have been in an opposing direction. So meaning, we are not going to have E1 plus E2. We will be having E1 minus E2. But in our case, they are in a clockwise direction. So therefore, we are going to have E1 plus E2. So E1 plus E2 is equals to the first resistor we meet is R1, and the current flowing through it is I1. So I1 R1 plus the second resistor is this one R2, and the current flowing still is I1. So I1 R2. We still have a third resistor, which is R3. Now R3 is being shared in both loop 1 and loop 2. So it is plus. The current flowing through this is I1 plus I2. So we are going to have I1 plus I2, you multiply by R3. So we substitute in our values. E1 is 3, E2 is 6. So we have 3 plus 6 is equals to 1.5 I1 plus 2.5 I1 plus 5 I1. I have opened the bracket. The value for R3 is 5. So 5 I1 plus 5 I2. So we collect the like terms and we simplify. We get 9 is equals to. So when you take 1.5 I1 plus 2.5 I1 So we are going to have 1.5 plus 2.5. We get 4. And then plus 5, we get 9. So we are going to have 9i1 plus 5i2. Then the next one, we come and form our equation 2. Equation for loop 2. Now in equation for loop 2, we are having one source of 4 volts. So we're going to have E3 is equals to, remember we are moving in anti-clockwise. So the first resistor is this one, and the current flowing through it is I2. And then the next resistor is this one, and the current flowing is I1 plus I2. So we are going to have R4 I2 plus R3 into bracket I1 plus I2. We substitute in E3 is 4, R4 is 2, and R3 is 5. So 4 is equals to 2i2 plus 5 into I1 plus I2. We open the bracket. 4 is equals to 2i2 plus 5i1 plus 5i2. We collect like terms. 4 is equals to 5i1 plus 7i2. So this one is our equation 2, and this one is our equation 1. So we solve these the two equations, this one and this one, simultaneously, either by elimination or substitution. So we are going to have 9 is equals to 9i1 plus 5i2, and 4 is equals to 5i1 plus 7i2. So we solve simultaneously. We eliminate, I'm going to use elimination. So let us eliminate I1. How do we eliminate I1? By multiplying by 5 and multiplying the second equation by 9. So the whole of this by 5, the whole of this by 9. In order to make the I1 the same and eliminate. So you're going to have 45 is equals to 45. I1 plus 25, I2. And then we're going to have 36 is equals to 45 I1 plus 63 I2. So how do we eliminate? It is plus and plus. How do we eliminate? By subtracting. So 45 I1 minus 45 I1, we get 0. 25 I2, remember it is positive, so it is plus 25 I2 minus plus. When you take negative, you multiply by plus, you get minus. So you're going to have 25 minus 63, you get minus 38 I2. 45 minus 36, you get 9. You solve for I2. So we have 9 is equals to minus 38 I2. over minus 38 over minus 38, we get I2 is equals to negative 0.2368 amperes. We solve for 1, that is I1, by using, that is substituting for I2 in either equation 1 or equation 2. So when you substitute I2 in either equation 1 or 2, you're going to get I1 as 1.1316 amperes. So now, how do we get the current through the 5 ohm? In the question, you are supposed to get the current flowing through the 5 ohm. The 5 ohm is here. So how do you get the current through this? Now the current passing through this is I1 plus I2. So simply you go and take your I1, you add to negative 0.2368. Therefore the current through the 5, current through 5 ohm is equals to 0.8948. And that is all.